Chapter Fundamental Concepts of Algebra for Grade 6. Topic Algebraic Terms and Types of Algebraic Expressions. Important terms covered in this video are algebraic terms, constant terms, factor, product, coefficient, that is numerical and literal coefficient, like and unlike terms, types of algebraic expressions, that is monomial, binomial, trinomial, and polynomial. Terms which are not polynomials. Hello everyone. In this video, we will understand what are algebraic terms and types of algebraic expressions. This topic is from chapter Fundamental Concepts of Algebra for Grade 6. In my previous video, I have explained what is algebraic expression. It is an expression formed by the combination of constant, variable, joined by one or more mathematical operations like plus, minus, multiplication or division. Now we will understand what are algebraic terms. Each part of an algebraic expression, like a constant or variable, their product or quotient of constant, joined by plus or minus sign, that is addition or subtraction, forms an algebraic term. Algebraic terms are the parts of an algebraic expressions like a constant, a variable, or their product or quotient of constant joined by addition or subtraction, that is plus or minus sign. For example, a plus 3. Here a is a variable, 3 is a constant. It is an algebraic expression where a is the first term and 3 is the second term. 4n minus 7m plus 9. Here minus and plus two operations are there. So here 4n is the first term, 7m is the second term and 9 is the third term. 8x minus y upon 5. In this example, 8x is the first term and y upon 5 is the second term of algebraic expression. Few important points we have to remember. That is, only the sign of plus and minus separate the terms. That means, terms are not separated by multiplication or division. When there is multiplication and division, then it is considered as single term. In this case, 4n, that is 4 into n. So, 4n is considered as single term. Algebraic term is also called as term. Next, y upon 5 is also considered as the single term. In this example, 4n, this term consists of a constant, that is 4, and a variable, that is n. Here 7m, here 7 is a constant and m is a variable. But 9, this is only a term which consists only of a numerical value, that is a constant. So such type of a term which only has a constant without any variable is called as the constant term. So constant term is without variable. For example, 2, 7 upon 9, minus 18, etc. Now we will understand what are factors and product. Factors are the variables and constant which are multiplied to get an answer. And by multiplying the factors, the answer which we get is called as the product. So here factors, each constant and each variable multiplied to get the product are called the factors. Product. It is the answer we get after multiplication of two or more constants or variables or both. For example, 23 into A into B. Here 23 is a factor, A is a factor, B is a factor. 23AB is a product. Now we will separate different algebraic terms in the given algebraic expression and we will write the number of terms present in each equation. First example is very simple, A plus 9. So the first term is A, second term is 9. So the total number of terms here are 2. Second example, X minus 3Y plus 5. So the first term is X, second term is minus 3Y and the third term is 5. So here also we write the term along with the sign. We are not writing sign for plus because it is understood that no sign means it is plus. So number of terms are 1, 2, 3 we have written here. Next is 4m. Here multiplication is there 4 into m that is 4m and we consider that as one term. So here only one term is present. 12 minus 7xyz. So the first term is 12. Second term is minus 7xyz. That means two terms are present in this algebraic expression. 3 minus 2n plus 5m square. So the first term is 3. Second term is minus 2n and the third term is 5m square. So that means total number of terms here are 3. P minus 1 upon 4q. So P is the first term and the second term is minus 1 upon 4q. So the number of terms here are 2. 5m minus m upon 2 plus 17n minus 3. So the first term here is 5m. Second algebraic term is minus m upon 2. Third term is 17n and the fourth term is minus 3. So total number of terms in this algebraic expressions are 4. Now we will understand what is coefficient of a term. Any factor or group of factors of a product is known as the coefficient of the remaining factors. This we will understand with the help of examples. First example is 3AB. So first we will find the coefficient of AB. Coefficient of AB is the remaining part of the product. So what is remaining? 3. That's why the coefficient of AB is 3. Next we will find the coefficient of B. So which part is remaining of the product? 3A. So here the coefficient of B is 3A. Now we will find the coefficient of A. So which part is remaining of a product? It's 3B. So the coefficient of A is equals to 3B. Next example, minus 12xyz. So first we will find the coefficient of xyz. So the remaining part is minus 12. Therefore, the coefficient of xyz is minus 12. Now we will find the coefficient of x. So coefficient of x will be the remaining part of the product, that is minus 12yz. So the coefficient of x is equals to minus 12yz. Next is coefficient of y. So which part is remaining? Minus 12xz. So the coefficient of y is minus 12xz. Next we will find the coefficient of z. So the remaining part of the product is minus 12xy. So here the coefficient of z is minus 12xy. Now we will understand the two parts of a coefficient. In a term, the numerical part is called as the numerical coefficient and the variable or the variable part of a term is called as the literal coefficient. For example, 5a. 5 is a numerical coefficient in this term and a is a literal coefficient. One important point we have to remember that when no number or numerical value is present in front of a variable, the numerical coefficient of that term is 1. When 1 is the numerical coefficient, we don't write it. We just write the literal coefficient and it is understood numerical coefficient is 1. For example, xy. So here it is the literal coefficient and it is understood that the numerical coefficient in this term is 1. So we have to remember, if in a term there is no number before a variable, then we consider the numerical coefficient of such a term as 1. Few examples are given to us. We will separate the numerical coefficient and literal coefficient of the terms. 3xy is the first example. So here numerical coefficient is the number that is 3. Variable forms the literal coefficient, so here xy is the literal coefficient. Next example is 3 upon 7 pq. So 3 upon 7 will form the numerical coefficient, whereas pq will form the literal coefficient. nn. So here it is understood no number is written in front of the variable, that means 1 is there. So 1 will form the numerical coefficient in this term and the literal coefficient is nn. Next example, the numerical coefficient is 32 and the literal coefficient is a square b square. Now we will see what are like terms and unlike terms. On the basis of literal coefficient, there are two types of terms, that is like terms and unlike terms. Like terms have same literal coefficient. For example, AB 7AB minus 9AB. Here 1, 7 and minus 9 are the numeral coefficients, whereas AB, AB, AB are literal coefficients. These are common or same, so it is called as like terms. Unlike terms, they have different literal coefficients. For example, 3x, 5xy, 8xyz. Here x is the literal coefficient, here xy is the literal coefficient and here xyz are the literal coefficients. So here they are different, so this is called as unlike terms. Next we will understand what are types of algebraic expressions. Depending upon the number of terms in an algebraic expressions, they are classified into different types. First type is monomial. Mono means one. So when only one term is present in an algebraic expression, it is called as monomial. For example, 3x, n or 5 upon 7n or 7b into cd. If it is given 7b into cd, finally it will become 7b cd. So it becomes one term. I have already explained that when multiplication is there, it is considered as single term. In this example, 6m divided by n. So we can write this in this way, 6m upon n, and this will be considered as one term. Next example is minus 9r. So all these are the examples of monomial. Next is binomial. Bi means two. That means here two terms are present. For example, 3a plus 2b. So here 3a is the first term, 2b is the second term. In second example, x minus y upon 4, x is the first term and y upon 4 is the second term. 3m plus 8n upon 5, here 3m is the first term and 8n upon 5 is the second term. So again two terms are present. Next type is trinomial. Tri means 3. When 3 terms are present in an algebraic expression, it is called as trinomial. For example, a minus 2d plus 5ad. A is the first term, 2d is the second term, 5ad is the third term. So 3 terms, so trinomial. Next example, 7n plus m plus 1 upon 4. So here 7m is the first term, m is the second term and 1 upon 4 is the third term. So here again 3 terms, so trinomial. Next example is 8p plus 4q upon 9 plus r. So 8p is the first term, 4q upon 9 is the second term and r is the third term. Next example, 5x plus 2y into z plus 8. Now here 2y into z is nothing but 2yz. So here the first term is 5x, second term is 2yz and the third term is 8. So again this is a trinomial example. Next is a minus 4b plus 5ab. Again, this algebraic expression consists of 3 terms. So it is trinomial. Polynomial. Poly means many. It consists of one or more terms. So here monomial, binomial and trinomial all are polynomial. There can be 4 or 5 or 6 n number of terms in polynomial. There are certain terms which are not considered as polynomials. There are various conditions, but we will study only 2 conditions in grade 6. First condition is when variable is present in denominator, then that term is not considered as polynomial. Second is negative exponent, that is power or degree. For example, if I am writing a raised to power minus 2. So this minus 2 is a exponent or power or degree. When it is negative, then that term is not considered as a polynomial. We will see few examples, that is 4 upon a. In this, a is present in denominator which is a variable, so it is not a polynomial. Similarly, in other examples like 2 upon b minus 3 or 7 plus 5 upon n or minus 7 upon y minus n upon m plus 7 or 3p upon 2q minus 5r plus 16. In all these examples, we can see that variable is present in denominator. So all these are examples which we can't consider as polynomials. One more condition, that is a raised to power 2 plus 2b minus 4 plus 9. So here minus 4 is present, that is a negative exponent. So this is also not considered as a polynomial. I hope you have understood the topics discussed in this video. See you in the next video. Till then, goodbye.